Okay, we're going to go ahead and start reviewing for the test. Going to try to get this review done in about 2 videos. This is number 1. First thing we're going to do is we're going to solve using graph or table. We got 3 problems here. First one says, what are my zeros? Zeros are very, very simple. Zeros are where it crosses the x-axis. So I have a 0 here and I have a 0 here. That means this is at -1 and this one is at 2. I also want to take this slightly further, and I want to know where it is equal to, let's go with 3. Where is it equal to 3? It's equal to 3 at this line right here. Do you see how it crosses the y-axis at 3? So it's equal to 3 here and equal to 3. Actually, I'm guessing that's 4. I'm sorry. This line actually crosses there. I apologize for that. There's a point there and there. So with graphs, you got to be real precise. So it's equal to -2 is a 0 and 3. So where it equals to 4 is those spots right there. Sorry about this one. Okay, let's look at the next one. It says, what are my roots? Same idea. We see where it crosses the x-axis. That's at -4 and +2. Let's go ahead and try a different one. Let's see where this is equal to 5. Do you see how here it's equal to 5? I draw a line across where y is equal to 5. I get a root here. Sorry, it's equal to 5 there and a solution there. That would be -3. That would be 1. If it just says zeros or roots, doesn't give you any equal to or that, you just find where it crosses the x-axis. If it equals to something, we draw a line there and look at them. My solutions. I'm going to assume by solutions we mean zeros. My zeros are where it is equal to 0. Okay, so that would be -2 and 3. Let's try something else, and let's say where this is equal to 14. If I have the equation set equal to 14, that would be here and here. So those would be -4 and 5. Okay, we're going to factor these next ones. Factoring is simply the box method. Let's go ahead and let's do 11 first. You always check the GCF. You always check the GCF first. If I'm looking at this, I have 3j squared minus 27j. My first step, I look for the GCF. Number-wise, 3 and 27 both have a 3 in common. Both of these have a j, so that is my greatest common factor. To finish factoring, I got to figure out what goes in the second part, my second factor. This is my first factor, which is my GCF. And I look over here, and I have 3 times 1, so I don't need to put anything there. J times j, so I need a j here. And now I need to get from 3 to -27, so that'll be -9. I already have my j, so that is factored completely. I am, again, going to take this just a little bit further, and I'm going to find my zeros. I'm going to find my solutions to this if this was set equal to 0. If we originally started out with this set equal to 0, I would then set 3j equal to 0 and j minus 9 equal to 0. If right here, I would divide by 3, and I get j is equal to 0. 0 divided by 3 is 0. And in this one, I would add 9. J would equal to +9. Those are my 2 solutions if we started out with this equal to 0. Okay, that's number 11. Let's do number 12. On number 12, we want to factor it. First thing I do is I look, do we have a greatest common factor? 2, 17, 21, no common factor. 17, I think, is prime, actually. I'm going to go ahead and draw my box. In the first box, I'm going to put 2b squared. Bottom right box, I'm going to put 21. First thing I want you to do is I want you to take the numbers in here. I don't care about the b. I just want the numbers. And I want 21 times 2. That's going to be 42. So I want you to factor 42. My factors are 1 and 42. We always start with number 1. 2 times 21. 3 goes into here. And what is 42? If I had a calculator, you can do this in a calculator. I'm actually going to show you a shortcut. If you want to factor 42, you can do 42 divided by x. And then you just look at the table. There's my 1 and 42, 2 and 21, 3 and 14. And you're just finding whole numbers. The next one is 6 and 7. Those are all my factors. They start repeating here, so I'm done at this point right there. We can divide the number we're factoring by x, and we can find all of them very quickly. Now I need to find out which ones add up to my b value. The b value I'm looking for is that 17. So let's go ahead and add these up. Plus, 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 plus. This is 43, 23, 14 plus 3 is 17, 6 plus 7 is 13. They're right here. Those are my peanut values, 3x and 14x. Perfect. Last thing we need to do, one and only once, we take GCF right here. 2 and 3 have nothing in common. Oh, this is a B and a B. They both have AB. Now that we've done the GCF, we're going to go ahead, look over here, 2b times b gets you 2b squared. B times 3 gets you 3b. How do we get to 14? Well, we're going to say multiply by 7. To check to make sure you did it right, 7 times 3 should be 21. We are good. That means my factors are now b plus 7, 2b plus 3. I'm going to take it just a little bit further because I'm going to say we're going to solve this. If I started off saying this was equal to 0, then I can say this was equal to 0, and I can solve this. I can solve for the zeros. Solve for the zeros, I would split this up. B plus 7 is equal to 0, and 2b plus 3 would be equal to 0. Minus 7 on both sides. I would get with b is equal to negative 7. And over here I would minus 3 first and get 2b is equal to negative 3. Then I have to divide by 2. b is equal to negative 3 over 2. If I was given this is equal to 0, I could solve it and do that. Okay. Next one, let's go ahead and look at a word problem. Let's go ahead, let's do 16. 16 is a pretty good problem for us to work on. A rectangle. My suggestion to you, anytime you're given a figure and there's not a picture for you, draw the picture. Always helps. At least it won't hurt. My area, I'm just going to put the area inside because that's everything we can touch in here. The area is x squared minus 17x plus 42. Did we already do this one? No. Okay. What we're going to do is we need to find the length, the width, and then the perimeter. Perimeter is simply adding all my sides up. So to find the length and the width, it's super simple. We factor it. And you're going to get a binomial here and a binomial here as my side lengths. So let's set that up. If you look, our box is almost set up for us. All this has to go in the box. My x squared goes here. My 42 goes here. When I multiply across to here, 42 times 1 is 42. So when I factor 42, I can go ahead and I can use my ones I used over here. The only difference is I see that I have 3 and 4 equals 17. Now, I need my middle term here to be negative. Just so we're clear, if you get a positive version, check and see if the negative version works. Negative 3 times negative 4, sorry, this is 14. Negative 3 times negative 14 is still positive 42. The negatives cancel out. So those are what we need. We need a negative 3x and a negative 14x. Now we go ahead, we can do some factoring. X and x, the only thing they have in common is an x. X times x is x squared. So that's a minus 3. And this is a minus 14. So those are my sides. So length and width are interchangeable. This can be x minus 14, and this will be x minus 3. If you switch that, that's okay. Now you have to remember that all my sides are equal. So this is also x minus 14, and this is also x minus 3. Okay. So when I'm doing the perimeter, I'm going to add all those up. My hint for the perimeter is add all the x's. X plus x plus x plus x is 4x. And then negative 14 plus negative 14 plus negative 3 plus negative 3. So we can do quit. We have 14 plus 14 plus 3 plus 3. And we get negative 34. Minus 34. And that's my perimeter. Okay, let's go ahead and we are going to do, I've done some examples for solving. The only thing I am going to talk about before we get done with this is if I have my equation, let's actually do 20. I have to put this in standard form and have to set it equal to 0. Somehow I have to get rid of this. What I'm going to do is I'm going to move it over here, but when I move it, it's going to become negative 7s squared. So when I rewrite this, I have 8s squared and negative 7s squared. Combining those just gives me s squared plus 3s plus 2, and now that's going to equal 0. Similarly, same thing over here. We're going to take the 16. It's going to come over here, but sorry, it's going to come right here at the end and become negative 16. So when I factor this and put it in the box, 3m squared minus 8m minus the 16, and now that's going to equal to 0. And the other situation you might have is something like this. We're going to take this negative 35. It's a k. It's going to go in the middle here, and it's going to become positive 35k. So we have 7k squared plus 35k, and that's going to be minus 42. And then you can plug that in the box and factor it like we did earlier. Let's go ahead and look at 24. 24. If I want the factors of this, easiest way I can tell you what would make this equal to 0, so I can do minus 5. 5 minus 5 is 0. This one plus 6. Negative 6 plus 6 would be 0. Basically, you're doing the opposites for both of these and factored form. So that would be factored form of that equation. Okay, let's go ahead and finish it up. Each side of a smaller square in a figure is each side of a smaller square. Okay, so we have a smaller square, and each of these are y long. Each of those are y long. Okay, since both of those are y long, then it says we are going to say that they are x longer. So now our square looks like this. Okay. This should look like something very familiar. It kind of looks like the box. Okay, so let's go ahead and fill this in. The area of this box is y squared. And what does that make these other boxes? This is xy, this is also xy, and this is x squared. So this is my total area. If I wanted my total area, my larger square, large total area, is going to be y squared, and these are peanut values here, plus 2xy plus x squared. Now the difference, the reason I did these in different colors, if it asks for a total area, that's the total area. But how much larger? Well, how much larger is just what I did in the orange. We have my larger area is 2xy right there plus x squared right there. And this can also be x squared plus 2xy.